It's important to note that the idea that the world is currently overpopulated at close to 8 billion people in 2022 is something of a myth. Many have expressed their concern for overpopulation, perhaps with an eye on the future. But credible sources that study population growth, global consumption, and environmental effects, such as the United Nations, are adamant that, for now at least, overpopulation is not the problem. With climate change, for example, it's been found that the richest 10% on Earth generates around 50% of global consumption-based carbon emissions. In contrast, the poorest half of the world generates just 10%. In other words, a wealthy minority is responsible for much of the problem, rather than a growing total. According to a 2012 paper published in the Journal of Sustainable Agriculture, we produce enough food to support a population of 10 billion people, and that's 10 years ago at the time of writing. We're projected to reach that population milestone sometime between 2050 and 2070, depending on which source you take. However, we also, unfortunately, know that food can be wasted by manufacturers in huge quantities, and the excess often doesn't reach people in need, creating poverty and other inequalities. In some regions, the situation is reportedly getting worse too, with inflation and disruption to supply chains among the reasons that we've seen food prices soar. Nevertheless, we've continually seen that the distribution of Earth's resources, rather than a fundamental lack of them, is the real issue. We have enough for more people than there currently are, but it's not appropriately spread. For today's question then, when we're looking at a significantly higher number than 10 billion people, it's clear that the issues we're currently experiencing, including energy misuse and food distribution, would have to be worked out tenfold. But when exactly could we reach this comparatively huge number of 100 billion? Even with current growth rates, which many current projections show are actually slowing, we're thinking centuries into the future. But let's imagine we hit 100 billion quite early, and somewhere around the 24th century. In this scenario, we've managed to avoid an apocalyptic event between now and then. We've curbed our emissions, we've invested in technology, and we've become an advanced, carbon-negative, probably space-faring planet. This sets us up perfectly to address Earth's growing population with genuine solutions, and we'll definitely need a lot of technology to look after 100 billion people. The first and most fundamental way in which we'll likely cope is via a number of people that will, by then, be living in space. It's a good bet that we won't have enough physical room on Earth to comfortably house everyone as we'd like to. But luckily, a 100 billion population will almost certainly have left Earth to explore other places in the solar system too. This potentially means large orbital stations, lunar and Martian colonies, Venusian cloud colonies, sprawling generation ships, or even human setups in the outer solar system on moons like Titan, Triton, and Europa. Many of these bodies are similar in size to Earth, so despite there being 100 billion of us, there'd still be room to go around. At this hypothetical point, people might even be born and raised on these distant worlds without ever needing or wanting to visit Earth at all. And while it's certainly plausible that we'd have started terraforming these worlds, we'd also be able to accomplish the first off-Earth breakthroughs without terraforming on a large scale, by living in enclosed, self-sufficient habitats. The next challenge is food and sustenance. Growing food locally for any small human settlement would be much easier to manage than trying to provide for all these outposts with produce from Earth. And fortunately, we'll always be able to grow fruits and vegetables in controlled greenhouse conditions. Meanwhile, it looks unlikely that we'd continue animal agriculture on newly colonized worlds due to the time, space, and energy that maintaining their huge habitats would require, not to mention getting farm produce off Earth to begin with and ensuring that the animals could even survive at all in such foreign environments. Fortunately, we are able to produce cultured meat, aka lab-grown or synthetic meat. Currently, it's difficult to obtain because it's expensive to produce, and it's still not clear exactly how much nutritional value it has versus either actual meat or a traditional meat substitute. But we're talking hundreds of years in the future here. By this point, we should be able to effectively grow cultured meat in labs and hopefully make it nutritional as well. It's also a concern that, currently, the process of creating cultured meat may not be more environmentally friendly, as it still requires a lot of energy. So those issues would need to be solved. The practice does, at least, take up far less space than traditional farming though. And anything that saves space, or water, or energy, anything that's more efficient in general, will be vital, both on Earth with a hugely increased population, and off Earth when that population spreads. Water is far simpler to acquire, mind you, since many places in the solar system have massive deposits of water ice, including on the Moon, Mars, and on icy moons like Europa and Enceladus. Alternatively, while shipping water around the solar system could be tricky because water is so heavy in large volumes, we'd likely have a large system of constant, slow-moving vessels, perhaps even ferrying water to and from Earth too, to provide for those that are still here. Similarly, energy should also be relatively easy to gather at this future time. We've also got the sun as a major renewable energy source, and it will remain that way for billions of years yet, which means constructing a Dyson sphere, or preferably a Dyson swarm, a fleet of solar-powered satellites to harvest the sun's energy without blocking out heat or light. Again, that energy could be transported around, perhaps via enormous, eco-friendly, and efficient batteries, to and from Earth and all other locales with a human presence. We might have enormous solar arrays in space, tidal generators on Europa, wind turbines on Venus, and so on, all geared to capturing enough energy to power a 100 billion population. Renewable methods such as those would be championed for their never-ending potential, but we could also use that seeming specter of future energy too: nuclear power. Though nuclear power on Earth is controversial because of the large risks that even a small malfunction poses, and because of the difficult-to-dispose-of waste, were we to put nuclear power plants in space, then disastrous meltdowns would happen far away. We know that space is already extremely radioactive regardless, so perhaps there'd be less risk, especially if the future plants were also fully automated. Finally though, we're going to need a lot of other resources to build all this infrastructure. And luckily, the solar system has plenty to go around. While there's understandable opposition to the idea of us mining asteroids and other planets in the future after seeing how mining has affected Earth in recent history, mining in space has the potential to be more ethical and sustainable. There are metal asteroids out there reportedly worth quintillions of dollars, literally because they are so resource-rich, and so, in the right hands, these could be extracted for the good of all humankind, and will of course need metal for building and transport, for example, but also for robotics and for laying the path toward more automation, in asteroid mining itself, for instance, and therefore more expansion at quicker than ever speeds. It would be all about meeting the material needs of our 100 billion people. And there are ways in which we could do it. Despite what dystopian fiction says, a one-day massive human population doesn't have to be a frightening doomsday scenario. Instead, it could inspire a new age, when we have access to so much more powerful and life-changing technology, and one in which we're ready, willing, and capable of exploring beyond our home planet. And that's how civilization could cope with 100 billion